Yeah, hi guys. So I finished my second chapter, and this chapter, what I studied is like different database, data storage options available, and like what goes inside them, and it talked about a little bit on briefly on the how conveniently we can use the databases, which internally is storing in memory in different formats, and this memory is eventually being storing in the ones or zeros format, and which is eventually being stored like governed through electric signals of ups and lows, highs and lows. So like how each layer is extracted, and we make use of different databases to create our own applications. So so to make the decision like which database to be utilized, we should know like uh, where and how the databases are designed, and how to make the optimum decision for it. So initially they talked about the business use cases, like to store the business information like the transactional data. We had I used to have IBM IMS systems. Then the idea of relational database came. Before that, there was also an idea of hierarchical database and network databases, but hierarchical stayed for some time, but network didn't actually took off much at that point of time. But yes, over the period of decade over decade, it keep coming back and going. But one thing that ruled from 1980s to 2010 will be relational, and still is being utilized in 2022 as well. So relational is in relational databases, basically relation is basically a table which is having tuples in it, which are in unordered sequence. Tuple is basically each row in that relation. And when we are having some schematic structure or similar kind of data coming up, relation stays the go-to choice till today as well. And but in some scenarios, like in what happened in like in 2010, the NoSQL came. NoSQL was basically hashtag NoSQL being utilized in the Twitter actually for just for attracting the attention of everyone. And it was not actually NoSQL, but the name was very catchy, so all the NoSQL databases are utilizing that name. And it was basically an open source conference and invitation for it in 2009, which became so famous and still being used. So for NoSQL databases, we have document databases basically, where we store the complete documents. So when don't have a set structure of the input document, or it can come from different objects in different schematic style. So then in storing in relational fixed schema, it becomes a challenge. So document databases, what it can do is like we can store directly write the complete document in a single go. And usually the use cases of document databases are where we don't have a lot of relation between two documents in between them. And uh, in MongoDB, we can write map reduce, and different query mechanisms were also discussed in detail. And uh, then they discuss about the graph databases. Graph databases are very useful when we have a many-to-many relationship and fluid structure as well. And there are two kinds of graph databases: property graph and the triple store graph. So property graphs are Neo4j and some other databases examples were given. And for triple store, basically we have like in property graph we have the concept of vertices and edges. So any relation will be an edge, and vertices will become objects, right? And for triple store, what happens is like we have subject, predicate, and object. Like Gunish lives in Delhi. So it becomes like I become the subject, lives in becomes a predicate, and object will become the place that I'm staying in. So we store the in the form of tuples, and we have multiple tuples over there. And for the programming language example, like Cypher, the programming language used for Neo4j, the examples of how like 30 line query in relational database will become around 3 or 4 lines query in graph databases. It was shown to us. And how in Spark SQL, basically SparkQL, sorry, not just Spark SQL. SparkQL is another graph query language for triple store, and how we can write the similar queries. Like it was the syntax was very similar to Cypher, I will say. How we can write the queries for querying the triple store structure as well. Then at the end, they also discussed about like how not all the problem statements can be covered in these three only. There are specific genome sequencing scenarios for DNA, large hadron colliders where petabyte scale data is, so where we make customized solutions so that we make the optimum resource usage specific for that particular problem statement. And then we also have specific scenarios where text searching or Elasticsearch kind of solutions become very important, which we will be discussing in later chapters. So that was quite the summary that I studied. We'll share soon the third chapter updates as well. Thank you.